Hi everyone, and welcome to this new video of EuCAPT video profiles, where we interview leading experts in Europe in theoretical cosmology and astroparticle physics. And today we have the pleasure of talking to Fernando Quevedo, who has been in Europe for a really, really long time. Now he is in not in Europe anymore, but he will tell us about that. So hi, Fernando.
Hello, hello, Cecilia. Nice to meet you.
Nice to meet you too.
Mhm.
And but yeah, I guess that the best way to start is to know a little bit more about you. I could say all your you had a long career and very successful one, and but it's better to start literally from the beginning. So, can you tell us a little bit about how you started being interested in science in general, and how did you know that you wanted to dedicate your life to physics?
Yes, well, it's a long story because I'm old. That's the sad to say, but yes. I am from Guatemala. So when I was a kid, I liked very much mathematics and
Mm,
things about physics, and so I kept reading many things about it. But when I had to go to the university, I didn't know that you could study physics, so that shows you my level of ignorance at that time. I didn't know that physics was a career to study. And actually in the National University in Guatemala, which is very big, there was no physics courses. There was no degree in physics
mm,
or mathematics. So I went there and I chose the career that had more mathematics and physics courses, which was engineering, systems engineering. So I studied I studied engineering for 2 years until I realized 2 years later that there was a small university that offers some physics and you could study physics. And then it so happens that we had an earthquake in Guatemala, and they
mm,
were going to close the national university. And so I decided to move to the other university. I moved from engineering to physics, and then I continue with the class career. But yes,
mm.
we don't have that much of a tradition in science, so in that sense, it was very, very, very few people who had studied physics, and I was lucky enough to learn from them.
Mm.
Yeah, and yes. So, but I
And
mean,
how
sorry. Mhm.
No, yeah, and so you studied physics. You changed your like the from one university to the other, right? To this other one where you studied physics,
Mhm.
and you say that there was no, well, that there was not big tradition of physicists there in Guatemala at the time. How did you know that basically it was possible to become a scientist and to do a PhD? And you went to the US,
Yes,
right?
yes, it came slowly. There's a key figure for us in Central America. His name is Robert Little from the University of Texas. He was a nuclear physicist, but dedicated to education. So he came to Central America in the 60s and realized that there was no physics at all. There were no physicists
Mm,
in the region. And so the only people he met were engineers. So he decided to send them to Texas to train them a little bit more on physics so that they can be more successful teachers in physics. And so I learned from them, from the first generations of them. So I was a second or third generation
okay.
that was brought to Texas. So when I graduated, essentially that was the only place that we could dream of going for a PhD because we knew someone there. Because otherwise, recommendation letter from someone from Guatemala who may not even be a physicist will not bring you anywhere
Mm,
for a PhD. So in that sense, I have always been very thankful to this Robert Little, Professor Robert Little, because he was the one who gave me the opportunity. And then I went to Austin, and there was a great group of doing physics, the
mm.
physics I wanted, which is high energy physics, and so I was very lucky to go to the right place at the right time. I would say in that sense.
So you did there your PhD under Weinberg, right?
Mhm.
And you always have talked very fondly of him, and it's a great memory for you. Would you say that that was the most exciting part of your career, or
Maybe we always say that when we are young, we always complain about our status until we go to the next stage and we realize that we were having the greatest time of our lives before. So that's what we say when we were students. I mean,
Mm,
it was a lot of fun to be always immersed and learning more and more and discussing with other fellow students and with the professors and learning so many things. And having Weinberg around, that was incredible.
mm,
He's such a great personality, but such a knowledgeable person that every single time that he opened his mouth, you learn something from him, and just his behavior about
mm.
science, questions he has in seminars, and so on. So, and but not only him, we had Bryce DeWitt, we had John Wheeler, so
Big
the
names, yeah.
this Sudarshan and Teitelbaum and Candelas and Polchinski later. So in that sense, I mean, we were extremely lucky to be in that place at that time because we've heard so many different opinions because they had different backgrounds. The relativity people and
Mm.
the Weinberg group, they were all different. So we were being exposed to all the different ways of approaching the deep questions in physics, which it was very, very, very exciting.
Were you interested from the start in string theory, like Fino string theory, or did it evolve with time?
No, I'm old enough that we saw string theory coming only in my last 2 years of my PhD.
Mm,
So, but this so when I started, supergravity was the big thing.
mm,
So I moved to supergravity. Weinberg was doing supergravity at that time. He had the famous equation for the potential and supergravity written in his blackboard all the time, essentially with the, uh, and uh, and then when string theory came, I mean, because of the work of Whitney and Green Schwartz and other people, essentially everybody in Austin moved to do string theory. So that was the last part of my thesis was
mm,
on string theory. And at that time, Weinberg was also doing string theory. He started, and then at some point he realized that it was not the field that he was going to do
mm,
more contributions, so he moved away and did the cosmology. But when I was there, he was still thinking.
mm.
So,
And where did you go after that?
well, I went to CERN, as my
Mm,
first postdoc, and yes, it was wonderful. I really
mm,
liked it very much. So it was my first time in Europe. It was just culturally was incredible, but also
mm,
I also felt well that I met a lot of famous people. I started working with them, like Ferrara and others, and their English was equally bad as mine. So I didn't feel that bad after all, because in Austin you feel that your English is always so bad, and yeah. So and then CERN is one of my favorite places, probably because
mm,
of it was the first place that I went as a postdoc, but also the diversity of people I met and people from different countries and different ideas. And precisely at that time, what I was doing, that was the main thing that people were doing at CERN. So, since at that time there were things about model building from string theory, conformal field theories, and realistic models, and so on. And there were several groups, and they will all have representations in at CERN. So there was a lot of
mm,
very interesting discussions and research. So I really enjoyed it very much. So I worked mostly with Luis Ibanez and Peter Nides at the time,
mm.
and I had a great memories about those years. Yeah.
Yeah, you've kept going to CERN quite often. How would you say that it has changed from your first postdoc to
Oh
nowadays?
yes, it has changed a lot. I was last year. I spent most of like 1 year there, and yes, um, partly is the fact that it's different generations. So now some has recycled somehow, and now we have a lot of the permanent staff that are all very young. And since I'm old, so in that sense, I had to restart getting to know the new people there.
Mm,
A friend of mine, Peter Nielsen, said that it's sad that you go there and now you don't recognize almost anybody. But the worst thing is that they don't recognize you neither.
mm,
Essentially, so in that sense, it was a you had to make new contacts. But I
Mm,
think yes, I still it's a wonderful place for me. Is a amazing that a place like that exists, and is key for all of us doing high energy physics.
mm,
People only talk about the experimental part, which is the top place in the world, but for theory, it has played an important role to be the central for all the theories to get together and to meet each other from all the countries.
yeah.
So I always keep saying that CERN is essentially one of my favorite places.
Yeah, I guess that is the capital of science in Europe, basically. All countries come together, and it has been also very important for the history of basically politics in Europe also. Like it has
Exactly.
meant a lot to
Yeah,
what we do here. Yeah.
yeah. So I think it's yeah, we
Mm,
should try to support as much as possible anything they do because to keep that aspect, which is sometimes is people don't mention and people only care about which is the new experiment or so,
mm.
but the place being a hub for scientists to come, that's is unique and it has made a big difference.
So how long did you live there?
Well, I have been so many times. Well, my first postdoc was 2 years. At that time, postdocs were 2 years,
Years.
and then I have been several times for 1 year. So
Yeah. So
yes.
after those 2 years, did you go to another postdoc?
Yes, I went to McGill
Oh,
for
okay.
McGill University McGill, for 1 year, and then immediately we decided to move on, and we went to Los Alamos.
Oh, okay.
Probably Montreal was too cold for a Guatemalan family. So, so we decided to move to Los Alamos, which was, I think it was very nice. I really enjoyed Los Alamos. At that time, they had a very nice theory group. And now, over
Hmm.
years, he had suffered from different bureaucratic constraints, but at that time was one of the top places in the US. And it was a beautiful place to live also,
Hmm.
the nature, so, and the historical aspect, which
Yeah,
is
of course.
so, yeah, so I was there for 2 years. And then we moved to Switzerland again, to the Neuchâtel.
Okay.
And so again, that was a very nice institute at that time, very small, but very good and a beautiful part of of Europe. And unfortunately, now it doesn't exist because it was moved to Bern. Uh,
Hmm.
the- but at that time, it was very good. And also, I allowed me to go to CERN once a week. So in that sense, for 4 years, I was also close to CERN.
That's nice.
Mm. and and
Hmm.
then we moved to Mexico as a now for permanent position.
Oh, okay.
Um, but at the same when I arrived to Mexico, I got this offer from Cambridge to go to Cambridge for 5 years, and so we stayed in a bit more than a year in Mexico, and I went to Cambridge.
You never
So
moved from one place to a closed one. You always had to go from one continent to the other.
yes, yeah, exactly.
Yeah. Hmm. So you stayed in Cambridge then for 5 years. The weather
Yeah,
in the UK was good enough for a Guatemaltecan, or
yeah, yeah,
was it good
definitely.
enough? Okay.
Yeah, it's an amazing place. It's just like a
Hmm.
dream to be there with all the. This is real history, and the history of science for me is it's incredible that I can be there uh, and be in the same place that all this and all the things have happened from Newton to Maxwell,
Iraq, yeah.
Iraq, and Thomson, everybody. So and even Hawking. So
Of course.
having that opportunity to be almost next door to Hawkins' office and seeing him working every day for me is one of the most inspiring things we can ever see. I mean, seeing this person with all these limitations, whatever problem you have, you can compare it to him, and still he was
Hmm.
uh, working every day and very optimistic about science and making his effort to do top research, and he was doing very good research and seeing him struggling with survival is such an inspiration for all of us.
Hmm.
Yes, so no, but I was lucky that after 2 years I got a permanent position there. So then I
Ah,
stayed
that's
there.
great. Yes.
Yes, so
Hmm. Was there when? when you moved then to ICTP or?
No, 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 no. I
Oh.
stayed there several years. How many years? More than 10 years in Cambridge
Hmm.
before going to ICTP. Then when I was on ICTP, um, of course, I went on leave from Cambridge. So Cambridge gave me, they were extremely generous. I always be thankful to them because usually they only give 1 year on leave and then you have to make up your mind to stay or to leave.
Hmm.
But and several cases had happened in that they were not giving any permission. So the head of the department asked me, well, what, why are you different from the other ones? If all the other ones have been giving only 1 year, why are you asking for 5 years? And because my position at ICDP was only for 5 years,
Hmm.
and then um, so I came up with the answer, which is well, the ICDP is not a competing institution to Cambridge, but is being the director of that institution is a service to the community. So in that sense, Cambridge will be helping the community as
Hmm.
ICTP does. So supporting ICTP was a way that Cambridge will support. And he liked the argument, and so I
Hmm.
got the 5 years.
That's great.
So that was very good. And then yes, and then yes, I moved to ICTP, which was uh, one of my other favorite places as CERN because I have Salam had been my role models essentially for all my career, and I had the opportunity to meet with him. And when I finished my PhD, I went to ICTP for 3 weeks before starting my postdoc at CERN. I had a nice opportunity to discuss with Salam. He was very kind and brought me to his office. We discussed a lot, and I had a lot of dreams about what to do in
Hmm.
physics in Central America and so on. He was putting me more or less on the reality that is not that easy. And so, but he had always been my role model. And then when I was asked to apply for his position, essentially many years later, it was like a dream for me
Hmm.
to take that opportunity. And luckily, I was chosen. So ICTP for me is is extremely close to my heart, and I
That's
like it.
nice.
It's, mhm.
So you finished there being like the director of of ICTP. Maybe we can mention a little bit more about that later. But you went back to Cambridge after that, and
After
you just
10
finished
years.
in. Hmm.
Yes, so they gave me 5 years, and then
Hmm.
the ICTP they asked me if I could wanted to stay another 5 years. So I had to ask
Okay.
again permission to get to Cambridge, and that 5 years was a lot, but 10 years was impossible. So they agree with the condition that I will go and teach the course every year.
Oh, okay.
So I stayed another 5 years at ICTP, but going essentially almost for 4 weeks a year to teach a
Hmm.
course, and then back. So uh, so again, I was very thankful for this open mindedness
Hmm.
from colleagues at Cambridge. And so of course, after 10 years at ICTP, there was uh, no more. to,
You didn't want to renew that
yeah.
time.
So
Back to
I
teaching.
think 10 years was enough. Yes.
Hmm.
So yes, I went back to Cambridge, and I was very pleased to go back.
That's nice. But you're not in Cambridge anymore, right?
Yes, yes. So I say that I like retirement, so I had done it twice. So I retired from ICTP
Hmm.
to go back to Cambridge. But unfortunately, in Cambridge, there is this rule that when you reach 67 years old, you have to retire.
Hmm.
Uh, so that means that I had to retire a couple of years ago, and then I got this offer to come to New York University in Abu Dhabi, and for which I think I'm very happy. So I can just
Hmm.
do research and do some teaching, and I feel still I can still be useful for the community for hopefully for a few more years.
Yeah.
So I'm very pleased to be here. Mhm.
Yeah. So still, I mean, it's great that you're saying all the time that well, it's not true, but that you are already an old physicist, but you're still in the process of moving and finding where where to do science. There's nothing more young than that, I would say.
Yeah, at least in spirit you feel young,
Mm.
but yeah,
Through
the
all
body.
this time that you're in all the different places that you've been, have you seen your research focus changing a lot, or have you been actually very driven from string phenol most of the time?
Yeah, no, that's yes. I uh, yes, since this string theory came so powerful when I was so young, so for me was that was my main subject. Was something with string theory that has some impact
Mm.
in the real world somehow, which is a big challenge, but it's a well-defined question. So I changed a little bit because I have to confess I didn't know almost anything about cosmology, and I had only one paper on cosmology, which with some collaborators because I needed their help because I was not an expert in the 1990s, and but only when I came to Cambridge and saw that cosmology was the big thing,
Mm.
I was doing string theory, so the natural thing for me was to start moving towards string theory and cosmology. Um, but I did before that, in the mid 90s, early 90s, um, I did a little bit of more theoretical research, mostly based on dualities.
Mm.
And then I came out with a thing that there's duality, non-abelian duality, bosonization, these kind of things that were also fascinating. So in that sense, I enjoy them very much. But overall, that was only a short period of my career, but most of it has been um, towards string theory and potential implications
Mm.
to cosmology or
To the
phenomenology.
universe, yeah.
Mhm.
Are you still working on that, or what is your focus today? What motivates you?
Yes, yes, it's the same. So that's the good thing about doing this is that you don't have to worry too much about the questions. The questions are always the same. So you
Mm.
have to understand whatever is experimental there, and you have the theory, and then you have to understand, the cosmological constant problem. You have to understand the dark matter, candidates for dark matter, or how supersymmetry is broken, if at all. On it. So the questions are already there, and you have to make a decision where you can make some contributions. Contrary to other areas, sub areas that you have to invent your own challenges because you want to understand quantum gravity overall, so you have to ask one concrete question that is comes from you. But in this sense, nature is giving you the question, so in that sense, you don't have to be that creative and just try to make a little bit of progress. Of course, the problem is that the reward can be very big, but achieving something that touches nature is very difficult. So in that sense, it's a long-term investment. We don't expect short-term results,
Mm.
um, unless we're lucky. So and yeah, so overall, I've been working a lot on the landscape, which is I think is an important development that happened in the last in this century, which is good. But there are plenty of things to be understood from using the landscape to really understand dark energy, which has been very controversial for 20 years. But I always say that is the worst solution to the cosmological constant problem, with the exception of all the other ones. So in that sense, I think that it is the most interesting at the
Mm.
moment, but still is it is not yet a solution until we understand better the structure of the landscape, how to populate it, and so
Mm.
on. So there are many open questions there, and and just getting the sitter by itself is challenging. There have been
Mm.
making progress over the years, but there have been some even debate in the last few years that to see how robust is getting a concrete de Sitter solution from string theory, which I think is very relevant. We're getting inflation and so on, which is interesting that can be tested eventually. And but probably my new kind of interest is anything related with gravitational waves. Uh, and I think is from the string theory perspective is string theory at the end. The most important part of the string theory that is a theory of gravity. And the biggest challenge is that we will always say it most probably will be testable at such high energies that we have no access at all of those high energies. But with gravitational waves, we change. the challenges of going to high energies to go into high frequencies.
Mm.
And in that sense, that challenge it looks that may be more realistic to achieve detections at high frequencies, not in the
Yeah.
next 5 years, but in the next 50 years. Whereas achieving uh, energies close to the Planck scale by experiments, we don't see anything. So
Yeah.
that instance, gravitational waves is such a open subject at the moment that just by exploring them by different the spectrum or different frequencies, by the experience with the electromagnetic waves, every order of magnitude you explore, there is something detectable. So
Mm.
it makes sense that in gravitational waves you can have something like that. And for string theory, it looks to me like the most promising avenue for the, and again, the long term, short
Mm.
term, I don't see that much
So
of yours.
in
Very lucky.
that kind of line, say that you could come back in 300 years to like to being alive, and you can ask one question to see if some problem in physics has been solved. What would be your go-to?
Well, so problem of physics is still the problem is the theory of quantum gravity. That's the main problem, and having some answer to that, I think
Mm.
that will essentially will have a lot of implications. So, and still, as good as string theory can be, it's not a full theory of quantum gravity. So that's the big thing we have to understand. Um, but then things you are different stages. First, first for me, I was so excited when the wrong bicep experiment came out, that I don't know, almost 10 years ago, that you say we are looking at the universe at the very beginning and you're seeing these tensor modes, and that will have been amazing in the same way that we see the cosmomacronic background that is only telling you physics at a few hundred thousand years after the Big Bang. This would be seeing
Mm.
physics very, very beginning. And so in that sense, I was so excited, and I still hope that either maybe not for tensor modes, we don't know, maybe, but also to any other exploration of gravitational waves is allows you to go all that far
Mm.
in the history of the universe. So that is something that we may expect that something can be seen.
Oh, that's nice.
Mm.
So yeah, I guess that more realistically, you would say the tensor modes, I guess.
Well, I don't know because there are some models that give you observable tensor modes, but at some
Mm.
point, if they don't see them in the next 5 to 10 years, it is difficult to conceive experiments that can go to such small values, and there's
Mm.
no, I don't have any real preference from one model or others. I have several models of inflation from string theory. Some of
Mm.
them give you tensor modes that can be tested in the next 5 years, which is good, but some of them give you tensor modes which are almost out
Mm.
of out of reach. So in that sense, it would be great if we to be lucky, but yes, we were
I
not lucky
see.
with supersymmetry so far. So in that sense, we
Mm.
can, we don't know.
That's great. Kind of parallel to all the physics, well, research life that you had, as we mentioned briefly earlier about the ICTP, you have dedicated a lot of time in your life to just the community and kind of, well, giving back to the community, but also building a lot to make it easy for everyone in the from different backgrounds to reach academia and be part of it. What do you think that is more or less the role of EuCAPT inside that? Do you think that um, that there is
Uh,
something like it
yes.
can be done in that direction?
Well, I don't know. But in principle, it's a European initiative, so but I think it's good to have the community working together. That's always
Mm.
a plus. Whenever there is support for when you need some funding or something, if the community, you always go building things from bottom up is the best way to try to achieve something. And if the community get together and agree what are the important things to do and what are the doable things. And so I think is very important. And there's tradition already in Europe or in the US when the plan for the high energy physics for the next 5 years or so, as the whole
Mm.
community come up and with the proposals, and the same thing in the US. And we actually were trying to do the same thing for Latin America. We have now a proposal for like a a forum for research infrastructures in the future, and
Mm.
that if you can do something in one country, you don't have to do it, and the other country will do something else, and then this kind of things. So in that sense, is having the community together to see what the questions are and how to approach them and how to work together, I think is very good.
Yeah.
Uh, Something that the being theorists, because usually as theorists we only work in small groups, 3 or 4 people, or at most 7 or so. But what we have learned in the past 25 years is that theories can be relevant in experimental initiatives. And as you can see with Planck and even WMAP, and so some of the
Mm.
theories play important role. And now you can see many theories involved in many of the experiments from Euclid to Lisa and so on. And I think that's is good also for the community that
Mm.
the theories can actually take some responsibility in the future of the experimental searches. And so having a combination between the theories and experimentalists is always is very helpful. I mean, very
Mm.
helpful.
And yeah, you're right that this is UCAPT is more like European, but of course you're dedicated to different regions in the world. Is this something that you still think about, this ICTP uh, type of institutions, or well, not only institutions, sorry, but initiatives? Is this something you still dedicate your time to?
Yes, actually, yes. Yes, in these things, as when I told you about Latin America, we have now created an association for high energy physics in Latin America.
Mm.
So we are finishing a paper, hopefully next week, about the productivity of all Latin America through since the beginning of physics until now. How different countries have been performing, number of publications, citations, and in comparison between one country and another one, compared with the rest of the world, the
Mm.
gender issue, there's just how bad it is compared to other regions. And so I think that that's an important information to have in order to plan for the future. So, well, how is it that
Mm.
we're doing? What is it that we're not doing correctly, and what is it that can be done in the future? So that I think is very, very, very good. Um, and then I try to be as helpful as possible within the ICTP community, because I got to know many people from many countries.
Mm.
Uh, we started several institutes, like the one in Brazil, and now we have some in Rwanda and so on. And so if I can be of any help, I always contact them or be in touch with them, because I think that's a way of incorporating the communities from developing countries in the bigger communities, which
Mm.
and so yes, I try to do my best. Even thinking here in my new position, maybe here there may be some chance to be part of some international initiative for support scientists from developing countries.
Mm.
So
No, yeah,
and
that's
yeah, so
wonderful. Yes, and it's important, of course. It's very important to take care of
yes,
these
yes.
things.
Yes, we always say that the talent there is no counterexample to that, but I think that talent is uniformly distributed. So the only difference between why some countries do better than others is because people have had more opportunities, but you provide
Mm.
opportunities to people, so people at some point they perform, so in that sense, then
Mm.
it's important to keep that active. Yeah.
That's nice. In this aspect, kind of focusing more on like the young people and new talent coming into academia, what are the advice you would give to yourself or to someone that is coming to academia today?
Um, Well, be as broad as possible, because we never know how the research is moving. So it's good. It's good to not to concentrate on one thing, but to be broad.
Mm.
Um, I'm impressed with all these things on machine learning, but there's have been some developments that are changing our way of doing research and
Mm.
will be important in the future. And uh, and also, if you learn about that and you don't get a job in academia, it will be useful for the private sector. So in that sense, it's good to learn about it. And the example I keep telling the students now is the Nobel Prize for chemistry this year, well, this year. it was given for people who essentially are computer scientists, and they may not have known that much about chemistry, but
Mm.
they identify one concrete question and they managed to have solutions. So in that sense, breakthroughs in science can be achieved by those kind of techniques that we don't have available in our time. So I think for young people, it's important to at least be familiar with this as a tool, maybe, but,
Mm.
that's one of the things that can go. And yes, and then we never know where progress will come. So in that sense, is worth to be as much informed as
As broad as
possible.
possible.
Mhm.
That's great. Well, I think that we're going to end it up here. Thanks a lot, Fernando, for the time
Yeah.
and the answers. It was a wonderful conversation.
Mhm.
And thanks everyone for watching the video. We'll see you next time. Goodbye.
Yeah. Bye bye, Sergio. Thank you.
Bye.